Welcome everyone. I am your favorite physics teacher, TS sir, a teacher by choice, not by chance. Today we will be discussing another popular misconception. So the question is about why the power which is produced in the power plant is transmitted at very high voltage. You might have seen 22,000 volt power lines, right, which carry power from the power plant to our city and villages. So here is a schematic diagram. So here power is produced. So here power is produced in thermal power plant or any power plant. So we have various kinds of power plants like thermal power plant, hydroelectric power plant, nuclear power plant. So these power plants, they basically work based on the principle of Faraday's law, electromagnetic induction, and power is produced there. Once the power is produced there, so here we have a transformer which is called as step-up transformer. So here the step-up transformer converts the power into high voltage and low current. So the step-up transformer, it converts the power into high voltage and low current, and then this high voltage and low current, it gets transmitted across the power lines, which generally we see in our fields, right? Big towers, and these are the transformers in our cities and villages. Now these wires, they connect the transformers in the power plant, which are generally located near waterfalls, inside jungles, to the transformers near our cities and villages. So these wires, these are thousands of kilometers long. So the question is, here the power gets transmitted at high voltage low current, and here the power again is converted into low voltage high current, and then it is used in our household supply. So the question is, why it is converted into high voltage low current and then it is transmitted? Why can't it be directly transmitted? That's the question. So the misconception comes here because, okay, so I will divide this video into three parts. First, now I have stated the question, and then I will give you the answer, and then I will discuss why this answer seems contradictory to our intuition, to our feeling, why we feel this answer is wrong, what is the misconception, what is the default set pattern of thinking because of which we get confused, and then I will discuss the right way of thinking and what is wrong with the present way of thinking. So this question or this video I am making for a 10th class student, but most of the time even 12th class students also have this doubt. So to know the answer, you need to continue to watch till the end of the video. Okay, so let's start. So the question is, why the power is converted into high voltage low current and then transmitted? ना यहाँ से high voltage low current करेंगे क्यों, फिर यहाँ पर फिर उसको वापस low voltage करेंगे क्यों? Generally ऐसे मान लेते हैं कि here it is converted to, let's say, 22,000 volts, and here it is 22,000 volt, that is converted again to, let's say, 220 volt. Let's say here it was produced at 220 volt. तो 220 को 22,000 करेंगे क्यों, फिर 22,000 को 220 करेंगे क्यों? सीधे 220 वोल्ट में प्रोडक्शन किए थे, उसी को सप्लाई करो, 220 वोल्ट को यूज करो. So the answer is, here you see the wires. These wires are thousands of kilometers long, and whenever there is current flow in wires, there will be heat production. What is the formula for heat production? It is I square RT, right? R is the resistance of the wires. So we want to decrease the transmission loss. So the answer is, we want to decrease transmission loss. Transmission loss in the wires is I square RT. If we want to decrease transmission loss, we need to decrease I. To decrease I, here we have to increase V. So to decrease I, we need to increase V here. Therefore this power supply, it gets converted into high voltage so that it can be low current. So that now when that power is supplied at low current, although this R, it is very high. Why it is very high? The resistance of a simple wire is very less. Why the resistance of this wire is very high? Because even if it is a simple wire, these wires are thousands of kilometers. Therefore, this R is very high. So to decrease transmission loss, we want to decrease I. To decrease I, we want to increase V. So power equal to VI. Try to remember this. Power equal to VI. Here we have certain amount of power supply, right? And that power can be supplied in various ways. For example, look at this. Let's say power equal to 220 joule. Let's say power equal to 220 joule. Now this 220 joule, I can write this as 220 volt into 1 ampere, isn't it? I can write down this as 220 volt in 1 ampere, power equal to VI. Or I can write down this as 2200 volt into 0.1 ampere. Or I can write down this as 22000 volt into 0.01 ampere. You see, it is the same power, 220 joule. Now I can supply it at 220 volt 1 ampere, or I can supply it at 2200 volt 0.1 ampere, or I can supply it at 22,000 volt into 0.01 ampere. But if I supply like this, then you see the I is very small, then I square RT will be very small, so the transmission loss in the wires will be very small. Therefore, we convert the power produced into high voltage low current and then we transmit it. Okay, now the confusion. Why students get confused after hearing this answer? Here this answer seems very nice. Okay, power equal to VI. If you increase V, then I decreases, and if you decrease I, then H decreases. So the answer is simple. What is the confusion here? Confusion here is because students try to remember. They remember Ohm's law, and when they remember Ohm's law, they remember that V equal to IR. V equal to IR. This is Ohm's law. So inside their mind, they start thinking that V equal to IR. If you increase I, then V gets increased. So if you increase I, V will get increased. If you decrease I, V will get decreased. So they inside their mind, they have a kind of feeling that V and I are directly proportional. V बढ़ेगा तो I बढ़ेगा, V कम होगा तो I कम होगा. ये दिमाग में आ जाता है. That's why यहाँ पे उनको समझ में नहीं आता ये किस तरह का बात हो रहा है कि V को बढ़ाने से I कम हो रहा है. So this is the confusion. So students, try to understand these are two different topics. Here I am writing this for a transformer. Here I am writing this for a resistor. Here the context is if you have a resistor and if you have a battery, then higher the potential difference across the battery or higher the potential difference across the resistor, higher will be the I, right? If you connect it to a battery of higher voltage, the current through the resistor will be higher. If you connect it to a battery of low voltage, then the current through the resistor will be low. So here we are talking in the context that given a resistor, we have opportunity to change V, then what is the effect on I? So given a resistor, if you increase V, I will increase. If you decrease V, I will decrease, right? That's the relation, that's the Ohm's law. Now, don't try to apply that here for this transformer. So for this transformer, here we are having certain amount of power input. So whatever is the amount of power input, let's assume that this transformer is 100% efficient. So whatever is the input power, that is the output power. So now the output power, that P output, that is fixed, and output power equal to VI. So you have options of transmitting a given amount of power at different voltages and currents. So what is the relation between V and I? You see the difference? Here we are talking of the relation between V and I for a given resistor. Here we are talking of the relation between V and I for a given amount of power. Aren't they two different things? Why are we trying to apply this one here? Therefore we get confused here, right? So here we are talking when the resistor is fixed, for higher V there will be higher current, for lower V there will be lower current. Here we are talking about a given amount of power. We have certain amount of power. How to send it? So if you are sending it at high voltage, then you have to send it at low current. If you are sending it at low voltage, then you have to send it at high current. So that's the relation. So here V is not directly proportional to I, V is inversely proportional to I. So higher the voltage, low will be the current, lower the current, heat production will be I square RT, which will be less. Hope this clarifies it. Looking forward to hear comments and suggestions from you. Thank you.